Professor, Department of Textile Technology, Vignan University. In this class, we are going to discuss about effect of fiber parameters on selection of fibers. Fiber parameters is a very important subject, and there are various fibers which possess different sort of parameters. Even though in yarn manufacturing we mainly concentrate on cotton, but there are other fibers which are also vastly used, like polyester, wool, silk, nylon, and many other fibers in terms of the apparels, whereas polypropylene and other fibers which will be used for many industrial applications. So in this class we are going to discuss about the topics like fiber parameters to be considered for spinning and the fiber quality index. What are the various fiber parameters to be considered for spinning? Okay. There are many number of parameters which are there, likely fiber length and length uniformity, fiber strength and elongation, fiber fineness, maturity, cleanliness, color of the cotton, stiffness of the cotton, and the chemical deposits. We are going to discuss in detail about each one parameter in this class. Okay. So let me ask you a question. Which fiber is referred as king of fibers? Yes, of course, hint is there in the screen. The cotton is considered as the king of fibers. Okay. Then who is the queen? Silk. Okay. So, well, coming back to the fiber parameters for spinning, there are many parameters which will affect the yarn parameters or even the subsequent operations or the end product also. Okay. So out of this, if you ask which one is the most important, I would say not one but three. Okay. Fiber length, strength and fineness. Fiber length, fiber strength and fiber fineness. Okay. The longer the fiber, the better it is. The longer the fiber, the better it is. If you consider cotton, generally only 20 to 40 mm is the fiber length, or the average or mean, or the effective fiber length if you consider. Okay. Then fiber strength. If you want stronger yarn and more durability for the shirts or the apparels or bed sheets or home curtains or furnishings, any material, if you want more durability, obviously we will be requiring more strength. More strength, more durability. Then fiber fineness. The finer the fibers, more number of fibers can be accumulated in the same count. That reflects in, again, more durability, very good comfort and other tactile properties of the fabrics. Okay. Apart from this, specific to cotton, the fiber maturity will be there. This property will not be applicable in case of polyester or polypropylene, these things. Why? Because the cotton is a seed fiber. The cotton is a seed fiber, whereas the maturity of all the fibers will be different. In terms of, if you consider one seed from the cotton ball, each seed consists around 5 lakh fibers on its surface. Okay. So in ginning process we will be separating and then we will align them, clean them and then arrange them and make into the yarn. Okay. So obviously the maturity of the fiber should be good enough and also the fiber should be clean enough. Also the fiber should be clean enough. The cleaner cotton produces obviously dirtyless or stainless fabrics. Okay. And it will be very difficult if we let the trash particles go along with the process. The bigger trash particles, maybe one stick Okay, maybe like a 10 inches stick or something if it is processed. So in the machine and all, what will happen? It will be made into million bits of small trash particles. It will remain with the yarn, and it will reduce the effectiveness or appealness of the yarn and fabric which are being produced. And we need to invest more amount of chemicals and other things in order to remove these trash particles. So that's why the more cleaner the fiber, the better it is, and the process also will be much better. And of course the fiber color. Fiber color, okay, what is there? Any color we can add through dyeing, isn't it? But of course, while mixing, or say imagine we need to prepare a very big consignment of the yarn. Okay, so all the color of this one should be uniform such that the final end output of the fabric also should be uniform in order to obtain a uniform shade. Okay, so that's why the fiber color is also an important parameter to consider. Okay, then there is something called as stiffness. Okay, stiffness also will be considered in certain cases, but not specific to cotton. And then sometimes some chemical deposits like honeydew content. Honeydew content is a kind of wax. Okay, it will remain onto the fiber surfaces. So what happens if you have more of this honeydew content? Then it will create more stickiness to the rollers and all, and then it will not allow the process to be much easy. So that's why these are some of the parameters: fiber length, fiber uniformity, length uniformity, strength uniformity, elongation. Elongation is nothing but the ability to recover after putting the stretch or strength. Okay. Then fineness, the more finer it is, the very smallest fibers, means the small diameter in fibers are much better. And all the fibers should be mature enough, and a fiber should be having clean surface, and it should have a good color, and the fiber should have good stiffness. So wool is having very good stiffness compared to cotton. Okay. And chemical deposits should be as less as possible. As in case of honeydew content, it should be less than 0.5%. Like if you see the fiber parameters versus yarn quality parameters. Okay. So the fiber length will constitute towards 22% of the yarn quality. Okay. And uniformity constitutes 20%. Okay. Then strength constitutes 20%. Then fiber elongation constitutes 5%. And fineness constitutes 15%. And cleanliness constitutes 3%. And all other parameters which we have discussed constitutes 15% in case of the ring yarn. Okay. Similarly, if the yarn is being produced for rotor yarns, then the length is 12%, uniformity is 17%, strength is 24%, elongation is 8%, fineness is 14%, cleanliness is 6%, and others are 19%. So what we are trying to understand here, if the fibers are being converted into a ring yarn, then the fiber length, then length uniformity obviously, then strength, then fineness. These are the three parameters which are top three parameters. But in case of a rotor yarn, what is happening? The fiber strength is much more important, then the uniformity, then the fiber length. Okay. So that is the reason the short stapled cottons, or say 20 mm or 22 mm, or sometimes even the Coomber noil. Coomber noil, new term we are learning. Coomber noil is the noil percentage or waste extracted from combing process during the yarn manufacture. Even these Coomber noils also will be contributed and made into a coarser yarns, means very thicker yarns. These can be used for packaging purpose or bed sheet manufacturings like Solapur, Kambal. So those kind of things, and heavy or more thicker fabrics can be created by using the rotor yarns. And rotor yarn itself is consist of, means it is more suitable for up to 40 counts only. So what is the takeaway from this table is, in case of ring yarn manufacturing, okay, the fiber length is the most important, okay, fiber length and its uniformity, then fiber strength, then fiber fineness. But in case of the rotor yarns, if the fiber strength is more important than the length, and then fiber uniformity should be better than the fiber length, okay. So depending upon the what kind of technology we are going to use in order to create the yarns, the parameters which need to be selected at the fiber stage are going to change. Are we clear at this time? So in case of a ring yarn, the ring yarn is the process, ring spinning is a process which is mostly used for manufacturing the yarn. Okay. As on today, we could say around 70 to 80% of the yarn is going to produced from ring yarn technology, and around 15 to 25% is going to be produced from rotor yarn. Only less than 5%, not even less than 5%, they say around 2% of the yarn only is being produced from other alternative technologies. Okay. Yeah. So we understood that cotton is the king of the fiber, which is mostly used, okay, but of course nowadays even polyester is coming into the picture. Then the cotton yarns are mainly produced in ring yarn, and for ring yarn, fiber length is the mostly used, okay. So if you consider various varieties of cottons, either in India or outside India, in the entire world, so the fiber length is one of the important parameter, and this length is 15 to 50 mm, 15 to 50 mm, okay. So generally most of the fibers, means based on this length, it is segregated, whether it is as a short staple, medium staple, long staple or extra long staple, okay. The more longer it is, the more quality it is considered, isn't it? As we have seen in the earlier slide, it contributes 22% of the yarn quality parameters, okay. So obviously based on the fiber length, the price of the cotton also will grow up. Based on the fiber length, the price of the cotton is also grows up. So the longer the cotton fiber length, the better will be the selling price, okay. So you may ask, then why can't we produce all varieties which are only longer length, okay. But we have different soil varieties. If you consider only in India, from Punjab to Kerala, there are various states and various geographical locations, and the type of soil, the humidity percentage, the relative humidity, means the moisture in the air is going to change, and the average rainfall of these geographical locations is also much more changing, okay. So what happens based on the rainfall and the type of soil and average humidity levels, all the varieties cannot be bred, or we cannot cultivate all the different varieties of cotton in one location, okay. So based on the location, there are various varieties of cotton which are available at various locations, okay. Like MCU5 is one of the variety which is mostly used in Andhra also, okay, not only in Andhra, in many places. MCU5, Bunny, Suvin, Pima, these are the names of the cottons, okay. We will understand these things much better later, okay. But for now you can understand that there are various types of genetic varieties of the cottons, so which also decides the fiber length, okay, and also the fiber yield, okay. Certain varieties the crop time is only 150 days, certain varieties the crop time is 270 days, almost double, okay. So accordingly the yield also will be different, okay. And also the ginning percentage, that means say the raw material for the cotton which is collected from the farm, which is referred as kapas, okay. If this kapas is 100 kg, the useful cotton fiber will vary between, can you guess what is the useful weight of the fibers from a 100 kg kapas would be? Yeah, okay, let me give you answer. So it will vary between 30 to 40%, 30 to 40%. Means 100 kg is the kapas which is collected from the farm. Only 30 kg to 40 kg is the useful fiber in this kapas. The remaining is seeds, trash, dust and various other parameters. Okay, yeah, okay, we'll come back to this fiber length. So 15 to 50 mm is the various varieties, and so it can be considered as if any fiber which is any fiber means any genetic variety where the average or the mean length of the fibers. We will see there are various categories in the fiber length also. Whether all the fibers are same length? No. In case of polyester where it is a manufactured fiber, so what happens if you take any fiber, almost it will be same length. But in case of cotton it is not like that, it is going to change. Okay. So what happens, we will see how to classify that. So 1 inch or less staple length is referred as short staple. So 1 inch to 1.125 inch means 25 to 28 mm is referred as medium staple. Then 1.15 to 1.37 inch. Okay, it is approximately 29 to 32 mm is long staple. Above 35 mm is considered as extra long staple fibers. Okay, so just now as we are discussing, the fiber length can be classified into various classes. Okay, it can be of staple length, it can be of mean length, it can be of upper quartile length, it can be of effective length, it can be of modal length and span length, upper half mean length. So this SL, span length and UHML, these two are most commonly used length mechanisms in terms of the fiber length. Okay. So the other parameters that can be used as uniformity index, uniformity ratio, short fiber content or floating fiber index, these also we will see. So the different types of fiber lengths will be used at different situations. Okay. So if you see this figure, what happens here? All the fibers from a single cotton pod, if it is taken and if it is arranged in a gradually reducing manner with respect to length of the fiber, it will create a curve similar to this. A curve similar to this. So what happens? 1 to 2% of the fibers which are at the maximum fiber length will be there. Okay, and some fibers will be there which will be having a decent amount of length, and then there will be gradually reducing. Okay, and in the end, if you see, there are few fibers which are having very less length of the fibers. Okay, so generally any fiber, if it is less than 0.5 inch, that means 12.8 mm, it will be considered as short fiber. Okay, so the edge, the short fiber content is generally not good for the manufacturing. Okay, we do not want short fibers. We do not want short fibers. We want good long length of the fibers. So if you consider the cotton pod, so what happens? Within one pod itself, there is so much of variation. So which length we should consider while buying the cotton or while selecting the process parameters based on this? So there are various types of lengths are there. So one of the most commonly used is the staple length. Most commonly used is the staple length when there is no machinery or then there is no objective evaluation is not available. Okay, conventionally when spinners go to the farmers and they purchase, so what they will do, they will take up the cotton with the hand and then they will arrange the effective fibers. Okay, and then they will create a small staple of fibers. Okay, this staple of fibers will be measured, and based on the staple length, the money will be paid to the farmer. Okay, according to USDA, United States Department of Agriculture, so the staple length is defined by USDA as the normal length of typical portion of staple fibers having relative humidity of 65% and temperature at 70 degree Fahrenheit without regard to value or quality. Okay. So it is a typical portion of staple fibers. Okay, at this RH and at this temperature, the typical portion of the staple fibers. Okay, the normal length. If you consider in mm and also in inches, the description, whether it is considered, whether it can be considered as a short staple, medium staple, or medium long staple, extra long staple. Again, the classification of the long fiber, short fiber is basically changes from country to country and one organization to another organization also. If you are producing various sets of counts of yarns, say 40s, 50s, 60s, this is the count of the yarn. At the end of the class we will learn more about count of the yarn, but generally you understand this. Say 60s yarn, 40s yarn. Okay, 40s yarn is coarser and 60s yarn is finer in terms of any system. We will see about these systems in the next slides. Okay, so staple length is the length which is generally done with the help of hand. Then Bayer sorter diagram, from this also we can obtain the effective length, upper quartile length, dispersion percentage, and of course the short fibers. As like in the earlier figure, if all the fibers are arranged from longest fiber to the shortest fiber, then this diagram is referred as Bayer sorter diagram. What is Bayer sorter? Why this diagram is called as Bayer sorter diagram? Bayer sorter is the instrument which will used to arrange these fibers in a constantly reducing mode. Okay, so it will be used. Bayer sorter is the machine name. Okay, so this diagram is referred as Bayer sorter diagram. Okay, so can we consider only the highest length of the fiber in order for purchasing or in order to put process settings? Will it give the proper result? No, it will not give the proper result. So we should have either effective length. Effective length is generally nearer to 25% of the fiber. Okay, so if all the fibers are arranged, the longest is 1 and the shortest is 100. So somewhere near to 20 to 25 will be the the effective length, but not exactly 20 to 25, means it will vary. There is certain process and all, it will be studied, means the students will be studied this in detail with respect to the textile testing subject. Okay, anyhow, so this is one method, the Bayer sorter method, and the other one is the span length, which is the most commonly used as on today. Most commonly used as on today. Okay. So far in Bayer sorter diagram or hand stapling, what we are talking about, we arrange all the fibers by holding at one end of the fiber. Okay. But in generally during the process and all, the fibers will never be arranged at one end. These are randomly arranged. These are randomly arranged. So this randomly arranged fibers, so in order to replicate the processes which are actually happening, so in order to use a length parameter, basically when the random catch point is one of the very important things in this. The randomly catch point means all the fibers are not arranged in a systematic way. When these are randomly arranged and at some point we are catching them. And we are catching them and then we are seeing the number of fibers which are there. Say this is the line A, okay. This is the line B. Okay. So there is some distance between A to B. Okay. If this distance is more, then what happens? The fibers after B point will be keep on reducing. Okay. Understood? One is the random catch point A and another one is the imaginary line of the point which is B. Okay. If the distance between A to B, if it is AB is increasing, then the number of fibers outside the B will be reducing. Okay. Now, the distance between, so the span length, it is either measured as 1% span length, 2.5% span length or 50% span length. 1% span length, 2.5% span length and 50% span length. Okay, 1% span length refers to the maximum extent or the longest fiber percentage. 2.5% fibers are the effective length, so that in order to put roller settings during the drafting of manufacturing these things and all will be used. So A to B, what happens? A to B is the distance are referred as span length. If 2.5% span length means the distance between A to B when only 2.5% of the fibers are outside the line B. Outside the line B. Understood? So 50% span length means 50% of the fibers are outside the B, but 50% of the fibers are between A and B. Means the edges of the fibers. Okay. So obviously what happens? 50% span length is much lesser than the 2.5% span length. Isn't it? So span length is one of the important concepts. I also request you to Google it and try to understand. If you are still confused, please we will discuss in detail person to person. So the most common span lengths are 2.5% span length and 50% span length. The 2.5% span length is defined as the length of fiber at which only 2.5% of the long fibers are excluded. It provides the reference length for roller drafting ratchet settings to be adjusted so only few fibers are broken. So what happens is there are drafting system. So in that what will happen? The fibers are stretched. Okay. So if the distance is too low, then same fiber will be under both the pair of rollers. So it may stretch and break the fiber. If it is too long, then the floating fibers are more, means there is no control of these fibers. So that's why the 2.5% span length is the mostly used in order to adjust the distances between the rollers. Okay. Then uniformity ratio and uniformity index. These are the two parameters which will give the uniformity, the length uniformity. As we understood, 20% of the effect of fiber uniformity is there on the yarn quality parameters. So that's why it is very important. In this curve, if you understand, so the span length, if it is kept in a curve, okay, whereas x-axis is the span length and y-axis is the percentage of the fibers. Okay, 50% span length and 25% span length. Sorry, 50% span length and 2.5% span length. Okay, so from this we can obtain, or in HVA system, we can obtain mean length and upper half mean length. Mean length is all the fibers mean length. Upper half mean length is nothing but only 50% of the fibers, the top 50% of the fibers if you consider, and if you take mean of this, it is referred as upper half mean length. So from these two, mean length and upper half mean length, the ratio, it is considered as uniformity index. If it is above 85, then the uniformity is said to be very, very good. Okay. If it is above 85, uniformity is said to be very good. 83 to 85, high. 80 to 82, average. 77 to 79, it is considered as low. Okay. And below 77 means the uniformity is very, very good. Then the other parameter is uniformity ratio. This is the ratio between it is not the ratio of mean length and upper half mean length, but it is the ratio of 50% span length and 2.5% span length. Okay. Generally, if it considers, if it is half or around 50%, it is very good. Okay. So above 48 is very good. 47 to 48 means high uniformity. Below 40% means very low. The relation between the uniformity index and ratio is with a factor of approximately 1.8. Okay, say if the uniformity ratio is 50, that means 50 into 1.8, that is 90. Uniformity index is 90. It is like that. So one is ICC mode, another one is HVI mode. HVI mode gives the uniformity index, ICC mode gives the uniformity ratio. Both indicates the uniformity of the fiber length. Okay, means how in the earlier as we discussed, the fibers which are keep on reducing in the bare sorted diagram, right? So based on this, if the uniformity ratio or index is low, means the steep is means the slope is very steep. Okay, if it is high, means the slope is not too steep. Okay. The next parameter is short fiber content. We want lesser short fiber content percentage. Okay. Why? Because it only increases the weight of the yarn or fabric, but it will not increase the properties of the textile material. Okay. The short fiber content percentage can be considered either by weight basis or by number basis. Number basis is considered only for the purpose of research and other things, but generally it is considered as on the weight basis. Okay, short fiber content percentage is 7%. That means 7% of the fibers does not contribute anything towards the strength of the yarn. Okay. So the presence of short fibers in the cotton, there are three problems. Okay. One is it increases the cost of processing waste and contributes to the weaker yarns and less efficient spinning. The spinning is not very efficient. Okay. So the long length fibers are mostly preferred due to the reduced number of fiber ends with higher yarn strength in the same length. Is it confusing? I hope not. So with longer fibers, same number of fibers will be there, but it produces stronger yarn. Okay. So this is short fiber content. Apart from this, the short fiber content will also leads to more number of nebs. Nebs are nothing but entanglements of the fibers. It also produces higher short fiber content leads to more number of nebs in the web or fibers. So it should be reduced. Okay, and these should be removed. Yeah, the yarn nebs and fibrous nebs both are not good. So the short fiber content is one of the most important parameter. It will create more number of nebs. Okay, so the lower amount of short fiber content will give a better quality of yarn. So with respect to length, another parameter is floating fiber index. As we discussed earlier, if more number of shorter fibers are there, so fibers will be floating in terms of the drafting system. We will discuss this one maybe in unit 2 and 3 in terms of the drafting system, floating fibers. So where we cannot grip onto the fibers. Okay, those are referred as floating fibers. So while processing, if we are able to observe more floating fibers, that means it means that more number of short fibers are there. Okay. So in order to consolidate the length, yarn production and quality, low fiber increase, long fibers increase production and also quality. Okay, longer the fibers, so what happens is less snaps, less breakages, obviously the productivity will be more and obviously the quality of the yarn which is being produced also will be more. And higher amount of short fibers influence end breakages, means breakage of the yarn will be there, then the wastage will be more, then the production and quality also will be less. Okay. So the yarn strength, short fiber reduces the yarn strength, short fiber causes the yarn unevenness, short fiber causes the yarn hairiness. So short fiber is not required. Okay. So far we discussed about fiber length, which is the most important parameter for spinning, and number 2 is fiber strength. Strength. Okay. So which is a dominating characteristics, and maximum strength of a fiber is approximately 60 cm per tex. in terms of the cotton. Of course, there are various high performance fibers where it will reach more than 100, but so the cotton, normally the breaking strength of the cotton is in between 15 to 40 centinewtons per tex. Okay, so in textile technology as a stream, the units are very much important. Okay, you need to make a very good note of units. Okay, centinewtons per tex. 1 Newton is equal to, you know Newton units, right? 1 kg is equal to 9.81 Newtons. Okay, 1 centinewton means centi is nothing but 100. Okay, centimeter. 1 meter is equal to 100 centimeters. Similarly, 1 Newton is equal to 100 centinewton. Okay, and tex. What is tex? Tex is a count system which we will discuss here within a brief time. Okay, so very weak cotton fibers like 15, 20 centinewton per tex and all, these should be avoided because the cotton will get ruptured during the processing in terms of blow room and carding. These are the various processes, and creation of the short fibers and deformation in yarn strength and uniformity will be caused. So the strength should be as good as possible. Generally, Egyptian cottons are referred as strongest cottons. Okay, and American cottons are somewhat lesser. Okay, so the strength is also expressed as tenacity. Tenacity is the strength of the fiber. So one instrument, it is referred as telometer, that also you will study in textile testing subject. So strength tester. For this, the fiber depth is taken between the two clamps and then it will be forced such that how much force it can withstand. Okay, kg force. So the unit for tenacity is either centinewton per tex or gram per tex. Gram per tex. Okay. So based on the how much amount of PSI, pounds per square inch, okay, so or gram per tex, pounds per square inch or gram per tex. In case if it is less than 35, it is considered as very low strength of the cotton, and if it is below 38, low. Then if it is in between 38 to 43, average strength. Then 43 to 48, good strength, and above 48, very good. Okay. Fiber tenacity is one of the measure. The same thing in case of PSI, like Shirley strength, fiber strength analyzer. So it is comes with the PSI. The same thing will be there. So just for our quick understanding, if you see, these are the various fibers which are available and which are referred with high tenacity to low tenacity. If you see the graphite fibers having the highest tenacity, then aramid fibers, which will be used in bulletproof casings and bulletproof fabrics, then polyethylene high strength, then glass, then polyester, nylon, cotton, silk, wool, rayon, acrylic, acetate, triacetate. So what happens? The tenacity is less. Okay. So if you consider cotton and silk, slightly those are same, but cotton is having slightly higher tenacity than the silk. So other unit again, grams per denier. Tex is 1 unit, denier is 1 unit. Okay. So far we have seen centinewton per tex, gram per tex, then gram per denier. These are the various units which can be expressed in terms of the tenacity of the strength. So if you see the cotton at the low, 5 grams per denier, highest. Okay. So the conversion between tex to denier is 9. Okay. So 5 gram per denier means it is equivalent to 5 into 9. That is 45. 45 gram per tex. Okay. So 5 gram per denier is cotton, then polyethylene, polypropylene, polyester and nylon. Okay. So in the earlier graph you might have seen nylon and polyester, where polyester is higher and here nylon is higher. Again, it depending upon the draw ratio and various other categories, but basically polyester and nylon are similar. If you ask the durability, nylon is more. Okay, but strength more or less both are same. Okay, so here as it is mentioned, text is weight in grams per 1000 meters length, and denier is weight in grams per 9000 meters length. Okay, text is weight in grams per 1000 meters length, and denier is weight in grams per 9000 meters length. So another important parameter is the fiber elongation. So it is not very majorly required for manufacturing into the yarns and fabrics. A minimum of 1 to 2% is required at the fabric stage. Minimum of 1 to 2% of the elongation is required at the fabric stage, but it should be higher during the processing stage. Like in terms of the manufacturing of yarn into fabric, it will be stretched by 6 to 7%. Okay, so it should not be lesser than that. So sufficient amount of elongation is there means it leads to lesser number of yarn breakages. Okay, so if the fiber elongation is good, yarn elongation also will be good in such cases. So cotton and wool fibers are having 6 to 10%, and for cotton, and 25 to 45% in case of wool. The woolen fibers are having more elongation. So if you see, in terms of the elongation, the rubber is having the highest elongation, then polyolefin, wool, acrylic, rayon, nylon, polyester, then silk is also having more elongation, then cotton, then least are like glass, graphite, polyethylene and aramid. Okay. So what we have discussed about the length uniformity, strength. Okay. The next major important parameters is the fineness. Fiber fineness. Fineness is another important characteristics of the fiber. The fineness determines how many fibers are present in the cross section of a yarn of a given thickness. We do not want to increase the thickness of the yarn, but if we want to increase its parameters, we can do it by increasing the number of fibers in its cross section. Okay, it can be done by using the finer fibers. Okay, so same volume will be there. If you are keeping smaller or finer fibers, more number of fibers can be accommodated. So obviously it will lead to better properties. But in generally, in order to produce any yarn, in terms of the yarn cross section, if you cut the yarn and see, minimum number of 30 fibers are required in order to produce a ring yarn. But in case of rotor and other yarns, it should be minimum is 100 fibers. But in case of a combed ring yarn, a minimum of 30 fibers should be there in the yarn cross section. Yeah. So the fiber fineness influences the spinning limit. So with the same cotton quality, we can produce 20s count also, which is coarser, and 40s count also, which is finer compared to 20s. So obviously we will go for 40s. The finer the yarn, obviously the price also will be higher, and always the spinner tries to go for the finest yarns. Okay. Then lusher, the finer fibers occupies more number of fibers, so the lusher of the fabric or the yarn also will be much good. Okay. So more number of fibers, less unevenness leads to more yarn evenness. And the handle of the fabric and yarn also will be much better, and yarn fullness will be good. And productivity during the process and there will be less number of yarn breakages and leads to more productivity. So fiber fineness, the measuring unit is, in case of cotton, it is referred as micronair value, which is approximately equivalent to micrograms per inch length of the cotton fiber. Okay. So generally it varies between 3 to 6. 3 means very fine fibers, and 3 to 4 means fine fibers, 4 to 5 is average, 5 to 6 is coarse, above 6 is very coarse. Okay. So these are the parameters which also defines the spinning limit. The next parameter is the fiber maturity. The cotton fiber consists of cell wall and lumen. Lumen is the empty space in the middle. The fiber is to be considered as ripe when this cell wall of the moisture swollen fiber represents 50 to 80% of the round cross section, and unripe means only 30 to 45% will be the cell wall, and if it is less than 25%, it is referred as a dead fiber. Okay, so less mature or immature fibers causes loss of yarn strength, more nubs, then more short fiber will be higher, then the dye ability will be changing. So the mature fiber will absorb good amount of dye particle and the immature fiber will absorb less amount of dye particle. So obviously it will create patches during once the fabric is made and dyed, and it is difficult to process in terms of the carding and all. So the fiber maturity is one of the important parameter. If you see in this figure, a mature fiber and immature fiber and a dead fiber. Okay. If you see the arrangement of cotton fiber, the structure, the physical structure of cotton fibers, it will be consist of several walls, primary walls, secondary walls, and in the middle the lumen. Lumen is the empty space. Okay. So if the growth, the primary wall and the secondary wall, if it is grown bigger, then the maturity of the cotton is better. Okay. And you can see also the shape of the cotton fiber. It is like a kidney bean or kidney bean shape. So the maturity coefficient, the fiber maturity coefficient, if it is less than 0.6, okay, if it is less than 0.6, it is considered as very immature and not good for processing. It should be generally more than 0.8. It should be generally more than 0.8. Again, the measurement part and all you will study in textile testing. As of now, you understand this figure and the range. And then the fiber cleanliness, another important parameter. So in case of 100 kg cotton, okay, if you see once it is ginned and all, the clean, how much good it is. If it is less than 1.2 kg of out of 100 kg of cotton which is from the ginning plant, if it is having less than 1.2 kg of the trash particles, it is considered as very clean. Okay. If it is less than 2%, it is clean, and if it is between 2 to 4%, it is mediumly clean. If it is more than 7, very dirty, 4 to 7 is dirty cotton. So the metal parts which are there in this are harmful for the spinning machines. The vegetable matters which will disturb the drafting system and also jam in terms of the carding, and mineral materials decay the rolling parts of the machine like sand particles and others. The next parameter is the color of the fiber. So the color gives an indication of fiber's ability to accept dyes in terms of the manufacturing process. The extra white fiber absorb a beautiful shades of the dye particle, okay, than a yellow stained cotton. Okay, so generally these are segregated into extra white, white, spotted cotton, tinged cotton, yellow stained cotton. The color of cotton with respect to machine can be determined by two parameters. One is RD value, that is reflectance value. Another one is plus B value, that is yellowness value. RD value and plus B value. These are generally measured in terms of the machine named as HVA. HVA is referred as high volume instruments. Reflectance indicates how bright or dull a sample is, and yellowness indicates the degree of color in pigmentation. Okay. Why? Because the cotton is generally white to yellowish only, as like our tooth color. And other chemical deposits, generally referred as honeydew, the sticky substances, it will be consisting of sugar, wax, oils and fats. So during spinning of sticky cottons, the relative humidity of air in the production area should be held as low as possible. and which is uncomfortable for the wearer or the operators of the machines and all. So what happens, it should be less than 0.5%. This is one of the very important thing, and it will consolidate all our today's class. Okay. So what are the various processes which are there at spinning stage and yarn quality stage and fabric quality stage, and each parameter which is responsible or slightly responsible or more responsible for it. Okay. So it gives a consolidation, like micronear value of the fiber. It will affect the cleaning efficiency, waste in terms of the spinning process. It affects the yarn evenness, dyeability, strength, elongation, and in terms of fabric quality, it affects the dyeability, hand, and also strength of the fabric. Okay. So the strength elongation is having very strong correlation between the fiber strength elongation is having very strong correlation to the fabric quality. Understood? Similarly, the trash, NEPs, and all the parameters will affect in terms of the parameters which are there in the subsequent processes. So in order to consolidate, we have several factors or several parameters which will indicate the fiber quality. Okay. So we have means the SITRA. SITRA is South India's Textile Research Association. South India's Textile Research Association. So it has come up with an FQI. FQI is Fiber Quality Index. Based on these parameters, like LUSM by F is referred as FQI. So from this we also can predict what will be the approximate yarn strength by using this cotton. If you produce certain count of yarn, what will be the strength and other parameters. Okay. So FQI is Fiber Quality Index, and FQI is LUSM by F. L is 2.5% span length of the fibers, and U is uniformity ratio percentage from the digital fibrograph, or uniformity ratio. It is nothing but the ratio between the 2.5% span length and 50% span length. Then S is the bundle strength in gram per text at 3 mm gauge length of stylometer. Then M is maturity coefficient, and F is fiber fineness in terms of the micrograms per inch. It will give FQI, Fiber Quality Index. So from this we can predict what will be the yarn strength if we produce yarn from these fibers. Okay. So far we have been telling about yarn count, and yarn count. What is yarn count? We will see now. Yarn count is a numerical expression to measure or to express fineness of the yarn. It is expressed as per either mass per unit length or length per unit mass. It can be expressed either mass per unit length or length per unit mass. Mass per unit length or length per unit mass. If it is expressed mass per unit length, it is referred as direct system of count system. If it is expressed length per unit mass, it is referred as indirect yarn numbering system or yarn count system. Okay. So in other ways, what happens in case of a direct count system? What happens if the count is more? That means the more thicker is the yarn. In terms of the indirect count system, if the count number is more, the finer the yarn is more finer and finer. Okay. So in direct system, more the number, thicker is the yarn. In indirect system, higher is the number, the finer is the yarn. Okay. So few direct yarn numbering systems. We will see only few. Okay. Denier and Tex. Denier and Tex. Denier is the number of grams weight per 9,000 meters. Tex is the weight in grams per 1000 meters length. Okay. As we understood, the direct yarn numbering or direct count system, where It is mass per unit length. Okay. So there are various systems are there in terms of the direct AR numbering systems, but most commonly used is text and linear, only two. Then indirect AR numbering system, which is length per unit mass. Okay, NE is quite commonly used. 40 is NE, 32 is NE. Now 32 is NE means 32 into 840 atoms present in a 1 LB. 1 LB is 453.6 grams or 1 pound. 1 LB is nothing but 1 pound. Okay. So 32 is NE means 32 into 840 atoms present in 1 LB. Similarly, we have NE, NM, then woolen system, worsted system and linen count. These are the various systems in terms of the indirect system, but we should understand perfectly in terms of NE system, which is quite commonly used for cotton yarn manufacturing. Yeah, small example for you. You please calculate by taking a pen and paper. A lee of 120 yards of cotton yarn weighs 25 grains. Okay, so calculate its count in the NE system. 1 LB is equal to 453.6 grams are also equivalent to 7000 grains. Okay. So in English count system, what happens if it is same processed, so the count system should be coming to 40s count. Okay. So you can try various examples with respect to considering different weight and different lengths of various yarns. Okay. So this is a ready reckoner for conversion of various direct systems and indirect systems, the yarn numbering conversion from one system to another system. For example, 30 stacks is there. So if you want to convert it into NE, so 590.5 is the conversion factor. So 590.5 divided by NE system, that is 30, so which gives 19.68. Okay, as in NE. So that's all for today's class. Thank you guys. Hope you understand. So it's a lot to digest since it is the initial classes. You should put little more extra efforts to go through all the material and to browse to various content and all, so that you will be very much comfortable and convenient. If you put sufficient efforts for the initial first unit and all, then it is very easy. If you stuck in the first unit itself, then it is very difficult for you to get on with the further topics. Okay, wish you all the best. Have a good day. Enjoy.